This is Don Larson again. We're ready to get started with our webinars, so let's begin. For our duration of our webinar, all attendees will be muted, but we'll turn you on again when we get to the Q&A session. And just want to bring to your attention, we do have some handouts, some little PDFs, one or two in the little drag and drop thing. I would invite you to drag those to your desktop, some literature background information, and then we will be posting questions, or you feel free to post questions at any time during the webinar. But like I said, we will be waiting to the end of the webinar to answer those. And if we don't get to all of them, we'll be sure to follow up with email. For those of you not familiar with Larson Software Technology, we're based in Houston, Texas. We are founded in 1984 and as graphics technology experts, and that has been our focus for over 30 years. We develop powerful, innovative graphic software and toolkits based on open standards. We were the developer of the first HTML5 CGM viewer, which eliminates the need for plugins in a browser to view CGMs. We're a member of the CGM Open Foundation that developed and maintains the CGM and Web CGM standards. Larson Software products are technology simplified the graphics workflow for technical publishing professionals. And we also have an online store where we sell desktop CGM viewers that you can access and purchase one of those with a credit card. So the agenda for today is we'll of course begin with an introduction, and then we'll go through briefly the 3D illustration process. We'll talk about the 3D data exchange, some of the common formats and some of the nuances therein, and then we'll get into authoring 3D data, and then we'll have an actual live demo with our product VizEx 3D. And then we'll move on to publishing 3D technical illustrations, some of the common file formats, how it relates to S1000D, and then talk about the 3D viewer requirements, and then a live demo of viewing 3D. And then we'll wrap up with a seminar and a Q&A session. And so with that said, let's turn it over to David for the introduction, and this David Manig for the remainder of our presentation.
Thank you, Don. Welcome, everybody. Thanks for joining us today. Yeah, it's, I think, a really exciting topic. Really, I think we're looking to the future here, if not today. So thanks for joining us. As probably many of you know on the call, the traditional technical illustrations are in a 2D format, or have been for a long time. But the illustrator strives to give them the appearance of being three-dimensional, to give that more value to the user. But I think today, and this is mainly down to software and hardware, we have more of the ability to, or the opportunity to create and deliver 3D illustrations. Obviously, this would need to be done electronically. It's not something we could put onto paper. So with this opportunity, there are also challenges. So how do we source the 3D data? This would usually come from a CAD department, engineering department. How do we author that information into some kind of usable form? So we'd have to select some software to do that. It could be the CAD software itself or something more specific. Where do we use the illustration in the manual? We probably wouldn't use it everywhere. We'd use it in select places. So what value does that actually give the end user? You want to obviously give them something that's beneficial to help them with a particular task. And then how do we deliver that? So I think most of us here would probably like to deliver in a web type of environment, internet, web browser, electronic manual. So, and there are obviously challenges to do that. We need, again, the right kind of technology to do that with. So during the webinar, we're going to try and point out the challenges and also how we might overcome them. So this is just a very kind of simplified view of what the process is, or what we see the process is. The only thing we've missed out here is there's obviously existing illustrations, 2D illustrations that will be kind of maintained for many years to come that probably will never be 3D. But if we're creating new illustrations, we have the opportunity to not only create illustrations from the 3D, 2D illustrations from the 3D, but also now also create and deliver perhaps 3D illustrations. So across the top there, we'd probably have to select the right formats. They might need to go into some kind of database to manage those 3D illustrations. And then they have to be distributed or displayed in some way for the end user to benefit from them. So we need some kind of 3D viewer that might be embedded in a web page or in an electronic manual. So in the same case is pretty much true for the 2D files at the moment. They're going through the same process, but obviously the viewer would be different, and the interactivity might be slightly different as well, if there is any within the file. So data exchange is kind of fundamental to this process. How do we get files from a CAD system, say, into an 3D authoring tool, which will enable us to create that 3D technical illustration? So we've got IGES and STEP, probably the primary ones, probably STEP more so than any other. And these are open formats. So the majority, if not all, CAD systems will actually support these file formats. So you can easily get your data and exchange it with other software using open formats. Sometimes the data exchange could also take place using native formats. So that's native to the software itself. But that's obviously there's a big dependency on that, your authoring software being able to support things like CATIA native and SolidWorks and so forth. So STEP is certainly a good alternative to using native and much easier to get. So we actually developed our own native format as well, talking of native formats. We did this, and we'll look at VizEx Edit 3D later on. And we develop this really because we wanted to hold the status of a file within our own format, and then maintain an archive of that. The reason we did it is obviously STEP and things like that. The original 3D files can be very large. So we wanted to optimize those, compress those down. And that's one of the reasons which we created our own format. You can also create an archive of your actual 3D illustrations as well. The other thing is that we're not going to show this today, but VizEx Edit 3D, you can convert from 3D to 2D with hidden line removal and save them as a CGM file. And no other format could really do that and keep the status of the file intact. So that's another reason we created our own format. So we've mentioned small file sizes, so it will drastically reduce the file size, which means you can load it a lot quicker. And then you can actually go back to a state where you might have exploded it later on, and it remains and comes back in that state. So it was important that we created that. We couldn't really use an like STEP to do that. So going back to 3D illustrations, what are the requirements? So what type of 3D illustrations are required? And I would say this is pretty much the same as what we would have in 2D. So we'd have exploded spare parts illustrations, assembly, disassembly illustrations, scheduled maintenance, repair and overhaul, and then more specialist type illustrations like transparent parts, ghosted images, and cutaway sectional illustrations as well. So all these we could use in 3D as we've done in 2D in the past. And I think there's some very specific requirements, certainly for technical manuals, is where we have an annotated illustration. So in this case, I've got an example of an exploded view where we can annotate the component. We can also have a tooltip by it, and that could also link us back to the model tree where we'd have the part number or other information about the part like quantity and so forth. Also the ability to change colors, so they might have warnings and cautions and things like that. So and the ability to link the illustration to that text parts list as well. So it's not quite as simple as just having an illustration that's just standing alone. It has to have some interaction with, say, text or a procedural kind of disassembly or repair. So there has to be some interaction between the illustration and the kind of the textual element as well. And this is where I talk about the functionality of the software where we want to actually create this 3D illustration. So there's specific functionality that you need as a writer, as an illustrator, that makes your life easier. So if you was to do this in a CAD program, then there'll be a lot of other tools, extraneous tools, that probably would get in your way and confuse you. So we tried to make this as simple as possible. So easily manipulate that 3D model, have common preset views like isometric that you can just click and it will automatically go to that. If you have the whole of the piece of equipment, then you probably need to break that down into sub-assemblies. So, and then explode those out. You can't explode the whole thing because it's too big. So, and also explode the model in constrained angles, add annotations, as I was just saying, and interactivity, so hyperlinks. Also, we wanted to give the ability to change the color of a particular item or component if that's needed, and make it transparent, and also do cutaways of that component as well. So a lot of the presentation today will be made up of demo, because I think that's the best way we can actually show you what we're talking about. So let's just go to VizEx Edit 3D. So this is the illustration program. What I'd like to highlight first of all, if we've got users of VizEx Edit out there, and that's really our 2D program. This is standalone, so you don't necessarily have to have. We don't need VizEx Edit, kind of the standard version. You can run this totally on its own and still create the files we see and take them into other software if required. So it is standalone. So I'll quickly go through the user interface. You can notice here we can open files or we can import or export files. So open and save really is using our native file format. So once we've imported the model, be it a step file, we can then save it as a VX 3D file and then reopen that in the future. We wouldn't need that step file anymore. So import, we could import, as I mentioned earlier, step and IGES. We also support VRML and also GLTF, which we'll talk about a bit later on. And we'll also look at export, because that's where we go to the publishing side. So where we publish an illustration to a format, then we can view in, say, a web browser. So we try to keep the interface as kind of clean as possible. So we have a specific tool section. A lot of these commands are also available through the right click, so you can get to them really quickly. So we'll talk about explosion, exploding the model. Display is pretty self-explanatory, that we can have a shaded view, wireframe. So things if you've handled CAD models before, you'll be familiar with. And then we've got preset views. So this is where I was talking about that in technical illustration, you might have an isometric view. So even though we've got a 3D view, you still might want to just see it in a nice plane of perspective, but you can also freely move it around as well, as you'll see. So at this point, what I've done is I've actually imported the step file. This is drill, you can see when I hover over it, it just highlights the part. And on the left-hand side, we have the model tree. So let's just move along the tabs. So this is our section view. We'll come back to that. And I'm just going to enable, our model tree is already enabled, but I'm going to enable our properties tree, which you'll see in a second, and I'll give you a brief overview of that. But if I select a part or part of a component on the model, it will automatically highlight it on this side. So I can see that's part of assembly. So immediately it automatically opens up the model tree to go to that particular part. You'll notice as well here that on the properties that it shows me the name and some other information about that particular part. The reason we did this is that we thought you might want to change the model tree name. So it's got handle at the moment, but this would allow me, if I double click in here, to actually change the text in here. So we could actually amend the model tree when it comes through into the viewer, which is really useful. Okay, let's just, so to close that properties box, I'm just gonna hit the X there. So I could easily get it back again by just moving over here and checking the box. Okay, so now I'm in the model tree. I can navigate around this really easily. So if I can also go in the opposite direction, and now if I want the engine, for instance, of this drill, this hand drill, then I can just click on it, and it will highlight it. You can probably just see the yellow inside there. And if I open up the plus sign, you can see all the components that make up the engine. So this is a really good example of like assemblies and sub-assemblies. Now, I probably wouldn't explode the whole drill. So what I would do is perhaps just take the engine and work on that separately. So if I right-click, I have the ability now to isolate that particular component or that assembly. And then we can just work with that on its own. So I don't know if you can see down here on the left-hand side that the tree is still visible, but it's got just crosses by it, so they're just hidden. So they are still there, but I can just now work on this particular part of the illustration. So within here, I can now move over the part again, and I can click on it, and to select it, I can even shift click here on the particular part, and I can perhaps modify the color of this particular part. So I might want to change the color of it to slightly darker blue. If I just clear the selection, you'll see that color is then applied to that particular part. You'd have to probably get authorization to do something like that. And it could be the CAD model has already the right colors for those particular parts, but if it doesn't, you always have that ability to change them. So one thing I haven't done is yet is I haven't moved this, so you can move it around. I don't know how it kind of looks on your connection, but hopefully you can see that we can move this around pretty quickly and look at the part. And we also have that ability to choose in this case, an isometric view, so I can always go through all the isometric. So this is, I think, useful for illustrators, because still, even though they're working in 3D now, is that the starting point could be an isometric type illustration. So we put that in as a preset, so it's easy to get to. Now I'm going to select the top component. You can see this is the cylinder, and if I right-click again, if you were fast, you probably saw that I could do transparency as well. So what I can do is I can just drag this over to the right and reduce the transparency. So again, it might be not easy to see, but now I'm seeing through that casing to the piston of the engine. So this is in illustrations terms, we call this really a ghosted image. So to see something behind in situ, we're just ghosting out the thing that's in front of it. So this can be really useful to actually distribute this information to your customer if they're not sure what's behind there. And we could also do that with the section view as well. We have the option now to use this in a 3D view, or we could actually take a snapshot almost, save it as a JPEG, and you could use it as a 2D illustration as well. I can always go back and modify this. So if I just select it correctly, go back and modify and say transparency, I can just turn that back off or just regulate that transparency. So there might be actually nothing there, but then you might as well just hide it. So now it will come back and we'll see it. Okay, so now I'm just going to go on to sections. So this has got its own specific tab. And we try to give the user an idea of what the section would look like. So if I click on here, and now doing a section like a half section through the whole of the assembly. If I hold the control key down, I can actually drag this backwards and forwards. So I can actually get to the view that I want of this piston. And then I can choose other views as well. So we might be looking down on this. And I can also just remove that plane so you could see it a bit better. And also the capping we see is where we have a solid part, but I could actually just remove that so we could see this. But capping is usually a good idea because it shows where the actual solid bits are. And then I could export this into a 2D view again or 3D. So we've tried to give as many options as possible here for different sections. So again, this is quite nice that I can just drag this backwards and forwards again and see more of the piston. And then we have like quarter sections. One of the other options I have here is to rotate. That just goes onto my other screen, I think, somewhere. Let's just, here we go. Sorry about that. So I can choose what axis I rotate around. So there might be the y-axis. You might be able to see a faint green line, and then 90 degrees and apply. So then I can bring that section through to here. So what's important here is that I could also save this as a 2D with hidden line removal as well. So we still have that option within VizEx 3D, or it could be a 3D file as well. So there's a lot of functionality within that section. So I can't go into everything today, but it could be really useful for like a functional type illustration where you see inside the component for the user. And then have the ability just to remove all, and we can get back to our view here. So what I'm going to do now, I'm just going to take this back into a view that I like. There you go. And now look at explosion. So we have a particular little menu here to choose how we want to explode this. I've got automatic, and that'll just explode this automatically. Doesn't always work as you might like, so we also give the option to be manual as well. So with manual, what I can do is I can select a part, and then I can click and drag it along the axis. And that would be the same with this part at the back as well. And let's take off the top. That will reveal the piston. So I'm just zooming in and out using my scroll key on my mouse. So I could move that a bit further away. And let's just let's take another part away. Let's take this one. We can still, so you can see I could do an automatic and then just fine tune it, perhaps. Okay, so I think I'll do that one final bit. So hopefully you see how easy it is for me just to explode this. And now what I probably want to do is add some annotations to it. So how do I do that? I basically right click, go to annotations, and add. And then I click and drag from there. Now I'm just going to keep this simple at the moment, so I'm just going to add in a 1. In fact, let me just do, I'm just going to change this. I'm just going to change the color of the background and the text to white. Say okay. Okay. And I'm going to add another one here to this part. Let's just make that 2. And obviously we'll do 1 over here. So just click and drag again. And 3. Okay. So I just wanted to do that quickly because I think one of the things when we were developing this is that what we saw is that even though we annotated them, then we have to have some connection to the part. So in other words, if I just move this away and I want to move this now to suit, the annotation goes with it. So it's actually got some connection to that part. And if I orbit around, then the annotations stay with their part. So that was an important thing we figured out really quickly. And if you notice that the numbers here always remain facing us, that's not as important here as it will be in the viewer. But what you don't want is these elements kind of acting in 3D space. So as I turn it, I see the back of the number 2. We want to always see it facing us. So I'm just going to add one more annotation here. So hopefully you see how easy it is to add this to the illustration. So the other thing we wanted to do is we're going to make this number 4. We wanted the ability to add color. So there could be where you want to highlight a particular part or give a warning for some reason for it. So what we did is say we have a caution, so we could make that the background yellow and the text black. And then we could call this a caution in the box here. And then I just say cover be hot or something like that. So now we've got some different elements on here and they appear now in the annotation. So we just wanted to give a bit more value to the annotation, and also the fact that it's still, you can see it's more evident now that it will rotate and it will stay facing us, which is important because if you're in a manual, you want to make sure you do the right thing. And if you're viewing it from the back, you won't be able to read it even, or it might be not be able to even see it. So that's annotations. So that's kind of a brief overview of VizEx Edit 3D. But what we probably need to do at this point, once we've done this, is export this as a file that we could then view in a web browser. And we'll talk about this in more detail in a second, but we have GLTF or GLB. In this case, it's a derivative of GLTF called GLB, which is a binary file. And that's one of the files we'll talk about now, about when we're publishing this to see it in a viewer. So at the moment, I'm just really authoring the file, not obviously viewing it how the end user would. So let's go back to the slides. So now we've authored our information, we need to publish it in some way. So if somebody could actually use it on the web, for instance, or within an electronic manual. One thing we found was, and this has been for a while now, there's a multitude of 3D formats to choose from. And as with the data exchange from the CAD system, we wanted to try and use an open file format, one that was readily available with technology and not owned by anybody. So it's not proprietary to a particular company. So some of the considerations we had when we chose a publishing format, we've got more than one, but we've got one primary one, I would say, is that it's easy to implement and view the model in a web browser. It's a small file size without sacrificing the quality. it has that ability to add that metadata, which is really important for interactive manuals. And the ability to link hotspots to external text, and also that the support of placarded text or billboarded where it's always facing you. So we looked at a few, and some of them we implemented. In fact, the only one we don't implement here is 3D PDF. But we have got X3D, we have got VRML, we have got GLTF, but we selected GLTF as our primary, and I'll talk about that in a bit more in a second. But with X3D, we did quite a lot of research into that. Although it's a good format and it's based on XML, it's quite heavy for viewing because of the file sizes. So we do support it, or it's supported within web browsers, but it's kind of a bit hefty format. VRML, actually X3D was based on VRML. So VRML has been around a long time. It's a good format, but it didn't do everything we wanted it to do. And that's in the end why we selected GLTF. 3D PDF is also interesting, but it doesn't really give us that integration that we would like. So it's more kind of a standalone. But it's still a good format, but it's not one we felt was give us enough flexibility that we wanted within a web browser. So GLTF, we implemented this after extensive investigation, and it's actually open. It's managed by the Kronos group, so the site is up there. It has two parts. It has GLTF and GLB. We primarily use GLB because it just creates one binary file that contains all the attributes that we need. It doesn't need a web browser. It doesn't need a plugin in a web browser, so that eliminates that kind of failing. It loads the models really quickly. You can optimize the size of the 3D file, and we've implemented that. And the other encouraging thing is Microsoft and Adobe, obviously very large software companies, support it really well. So if they're supporting it, they believe in it, then I think is a good reason for other companies to use it. So GLTF, actually tagged it the JPEG of 3D. So I think that's still not quite there, but it's possible. So what I might just do is just escape the main presentation and just go back to that file. So if I click on this now, you'll see that this is a GLB file inside PowerPoint. So the 3D functionality can be inside Excel and Word and so forth, which is quite, interesting. So they do support it, and so Adobe supports it as well. So let's just go back to that presentation. So I thought I'd do that quick demo there. So viewing GLTF, GLB files. So we really we felt this was the right way to go, and to view it, we could just obviously bring it straight in to a web browser, but we wanted to create an environment around it so it'd be easy to navigate, and also support some of the things like annotations and so forth. So we came up with a 3D viewer called VizEx View 3D, which I'll demo in a second. But we discovered there was nothing really off the shelf we felt that really worked well for technical manuals. So that's why we decided to create our own technology. And it's all based on open technologies. The viewer will have it as an SDK. In fact, it's available now as an SDK, so you can evaluate that online. So it has calls to it, so we have a documented API, and it's fully really customizable as a viewer for how perhaps you might want to use it. I know not everybody on the call is concerned with S1000D, but I thought it's worth just saying that there is a chapter within the S1000D specification. It has a lot of information in and gives a lot of guidelines, but there's nothing very specific in there. But what we've done is we kind of cherry picked the elements we felt would be good from guidelines for viewing mainly. So it doesn't specify any file format, but I would assume that they would encourage most people to use an open file format. At the moment, if you're going to put 3D files in, then you'd probably have to describe them in some kind of business rule according to the S1000D specification. So what we've done is we've taken what we felt are the best kind of guidelines from the spec and implemented in our viewer. So I'm not saying this viewer is compliant. There's nothing to validate against. But what we've taken is the best elements we think from the spec and implemented in our viewer. So I think the best thing to do at this point will probably to show it to you. So obviously go into a web browser. Okay. Right, so don't be confused here. We're now in Google. So this is the drill again. And I've opened it up so I can move it, I can orbit around it and so forth, move it around. So you can see the speed, even though I'm on a web browser, is still pretty good. And this is the whole of the drill. So it's not just that one element of it. And I can again select a part on here, so I can select elements and so forth, and I can bring up the model tree. So this is our kind of toolbar for the viewer, and you can see it's highlighted that particular component. So if I move it around, it will highlight it on here. So going back to that properties box, I could have changed this name over here to something easier to read or something more meaningful or not as long. So I could have actually changed the name, got rid of, say, the assembly ASM and just had engine or whatever I want to put in there. So we do have this interactivity between the model tree and the model itself. So the toolbar here is completely customizable within the SDK. So you don't have to have all the elements that we have here. You keep it very, very simple. So we even have we can open a file on the fly, perhaps. So you could just use it as a standalone viewer. We'll do that in a second. So model tree, we can scroll down it, we can select a part, and it will highlight it on here. Okay, so let me just, so some of the other things we have here, we can fit this to the screen. We have a home button that we can choose. We can scroll to take this down. We can just have more screen space by moving that. We can have ISO views, so we can choose the view that we want. We can bring up an x-axis, x and y-axis, so this should just flip it through these axes. We put this in because it's just nice to have some kind of point of reference, like the axis. It's very difficult to see probably, but I can see the y and x-axis, so I can just rotate around them very easily. And then we have rotate. So these are just really things for the user to get to the view that he wants. One of the things that they wanted in S1000D is orthographic views. So they want to be able to quickly go to different orthographic views on here. So just to probably orientate you in space. So we tried to build these things in, but this again is customizable. You don't have to put these in if you don't need them. They can just be left out. Okay, yeah, so fully customizable. Let me just, you can see on here, this is just another tab with a different model in here, but we've just been a bit extreme where we've got the different views so icon based. So you don't have to have just text. You could have an icon as opposed to text to customize the viewer for your end user or brand it in some way. If you've already got icons that you want to use, you could just use those instead. Okay, so I'm just going to go back to that file. I'm going to open hopefully some of the files we looked at earlier. So transparency. So let's see if we can open that up. Let's just move that, take that away, just zoom in. So I can also pan on here as well. So let's just zoom in again. So this was the transparency on the thing. Let's just see if we can move that into a better view. Okay, that's better. So you can see now the transparency on that particular part. You can see through that to the piston. So that would be useful, as I said, in the kind of the functional illustration. So that it does carry through into the viewer. So if you wanted transparency, we could see through a particular component. So I'm just using the open command. So you can see we support GLB and GLTF in here. I'm going to now look at the, say, section. So you can see this pretty quick to load. And there's the piston. And we can just see the, let's just see if we can move that around. You can see the piston inside the crankcase, which could be useful for, again, functional type illustrations. Doesn't want to rotate that at the moment. Okay. And the other one I want to show you is the link into text. So this is actually in our documentation evaluation for the viewer. So you can look at the examples that we created. So what I wanted to show here is that you can have a textual part. In this case, we just have a button that would link you to perhaps different illustrations or different views of that illustration. It could be a step procedure, perhaps, going through. So if I just click on, say, the punching machine, then I've got another 3D view. That's a GLTF. This is a GLB. And you can see on here that we've got a hyperlink to something external to the actual model. So this could take you to your website, perhaps, with this particular model on there. So you might go to more information about that particular drill or whatever, the product page. So that's, you would just enter that into the comment box, just put your web link in, and they will take you to a particular URL. And the other thing is that we wanted to look at animation. So this isn't, I'll show you another animation in a second. So we've got an animation here of just a figure. So I'm just going to move this around. Let's just do, let's say run. And it doesn't want to work. Okay. It was working. Okay. Why is it not? Perhaps there you go. Need to clear the selection. So animation is always a topic that comes up, and we'll discuss this in a bit more detail later on. What our plans are for animation. So at the moment, we're supporting it within our viewer environment, so you can play back animations. I've got another file that's probably a bit more relevant. So let me just go back to here, and I'm going to open up this particular animation, I think. Okay. So, here we go. And you'll notice that when the viewer finds that there is an animation file in here, it will automatically open it. So there we're just removing the cover. And I can still obviously move that around. So we're supporting animations within the viewer. At the moment, and we'll talk about that in a bit more detail, probably during the Q&A, about our support within VizEx Edit 3D and what our plans are there. But the viewer does support it. So if you already have animations, like this one was created in Blender, which is a free tool. So quite a complex tool, but it is possible to create GLB animations. Okay, the final one I want to look at is, just to end the demo, is the exploded view. Oh, that's interesting. Let me, I didn't realize we could get two things at the same time. That is really interesting. So let's reopen that. There we go. So here I have that annotation I did. You can see that it does billboard or placard the text. I can zoom in. All the colors are working, all the annotations are working with that particular part. So I think that's important from an illustration point of view, that we have that kind of functionality, and we can display it in a viewer for the end user. So I think that just about ends the viewing demo. Yeah. So as I said, it's available as an SDK, which means basically you would integrate it within your environment using our tools. So in conclusion, what's the user benefits for 3D? I think it's the ability to view the components from any viewpoint, which could lead to improved recognition of component parts, and particularly in spare parts illustrations. You could also perhaps view the parts in assembled or disassembled as part of a procedure where animation would be useful. And it could save time when performing kind of complex procedures. And downstream as well, GLTF can be used with augmented reality and virtual reality as well. So the same file could be used in some kind of workspace as well to with goggles or glasses, like VizEx do kind of AR glasses. So you don't have to wear big kind of goggles and so forth. If you're interested in evaluation, then we have evaluations for VizEx Edit 3D and VizEx View 3D. So you can, if you want to email me, just go ahead, or you can go to the website and there's the ability to request it there as well. So in summary, I think 3D data exchange is always the most challenging thing because it's right at the beginning. So to get hold of the data you're going to need to create this type of illustration is the first challenge. And I think with STEP, you've got a quick and easy way to get that from your engineering department. I think with publishing, the thing that's held back 3D being used at the moment in a lot of manuals is the cost to actually create it and then distribute it, amend it, and so forth. So what we've been focusing on is tools that are easy to use. When we create the file, then they're not huge, so they should be easy to distribute and use by the end user. They're in a web kind of environment where it's not proprietary. They don't have to download another 3D viewer to see or take advantage of that. And also to fulfill technical publications requirements like annotations and so forth, which are important for the end user to identify parts and so forth. We would always recommend an open format, and you don't have to use this format, but we think it's a really good one. It's light. It does everything we think we need to do from an illustration point of view. VizEx Edit 3D gives you that ability to save the 3D step file into a native format, which reduces the file size, which obviously then reduces the footprint on your hard drives and so forth. So that's important from a working with them point of view. But I think interoperability is always the objective. So we've tried to make GLTF and GLB like as interoperable as possible within our own software. So you could actually bring the GLB or GLTF file back in to VizEx Edit 3D and work on it again. So not native, but it certainly gives you that ability to work back on the file again, not throw it away. And I think we've gone down this route now. We're going to continue to enhance the 3D technology. Okay, so I'm just going to bring Don back in. Hopefully his mic is back up. Don't hear him at the moment. Don, are you there?
Yes, I'm here.
Thought you'd lost power. Okay, so yeah, thanks for the questions. One of them is around animation, and as I said, we don't really support it within VizEx Edit 3D at the moment, but we are exploring it, and I think it's quite likely we will support it. Don, do you want to make a comment?
Yeah, I agree. The plan is to support it. We're just not sure what needs to be there for. So we're just taking some time to research it and and carefully design what's useful for our users. So.
Yeah, I think we've looked at other software because there is other software out there that does animation. I mentioned Blender, which I've used, but if you've ever used it, it's very, very complicated. Like animation is just a kind of small part of it. And what we want to do is make it as easy as possible to animate parts, kind of moving away from the main body of the model. So we don't want to make it over complicated. And so that's our kind of strategy for the future of our 3D for animation. We'll research it and then we'll implement it when we feel we've got the right solution. Another question around 3D formats. I think I did mention it. So what other 3D publishing formats do we support? So we do support X3D and VRML. So you can, in theory, still use, if you've got viewers that support those formats, then we can still export to those. I can't promise that the annotations and so forth would work because really that's why we chose the GLTF format, because it was very kind of specific to that. So we can export in other formats other than GLTF for publishing. So GLTF is our primary one. So thank you. I think, is that it? Yeah, I think that's the questions. If anybody else wants to quickly post a question, we'll be happy to answer it. Otherwise, thanks for attending. It was quite a long, obviously, presentation, a lot of demo. So hopefully you enjoyed that. It's all live, so obviously live demoing is always risky, but I think everything performed well. So hopefully you've enjoyed the webinar today. So thank you for your attention. Thanks, Don, for your support. And we may have one more webinar before the end of the year. We have not decided yet. But if you have any questions, please email us and we'll try and answer them. So thanks again. Have a good day. And we'll hopefully speak to you again soon. Thank you.